Hello, in this video we're going to go through learning target 832, which is on arc measure. An arc measure is like the angle measure of an arc. So if we draw just like a quick sketch, we have a center and kind of like a pie slice. The arc measure is the same as the interior or central angle. So we can say the arc AB has a measure of x degrees, whatever this angle is inside. So arc AB has a measure of x degrees, which is the central angle. Remember, arc measure and arc length are two different things. So we're not talking about the distance, we're talking about the angle. And so we're going to use arc measures to be able to solve some problems to find missing measures within circles. And there's a couple helpful tips so that we can be successful with this. So first is kind of a reminder that all circles have a measure of 360 degrees. So the entire circle has a measure of 360 degrees. We're also going to lean on semicircles pretty heavily, so it's helpful to know the full circle, but then knowing that a semicircle has 180, that's super helpful for us. We can use that to our advantage, and we use that a lot. And to find a semicircle, we use any diameter. So if there's a diameter that goes all the way across, that cuts it in half. That means one side is a semicircle, the other side is as well. And lastly, vertical angles are congruent. Just be really careful that your vertical angles are actually vertical angles. And in order to do that, they have to be created with two diameters. So if two diameters exist and they cross each other, they'll create vertical angles. So if you need to pause that to get those helpful tips down, please do so. But I want to go through a few examples. So you're always going to be given a picture and then asked to find arcs. So as I draw the picture, I'm going to talk through how to do it so that you have as close to a picture, or as close to my picture as possible. So we're going to draw a vertical line straight up and down, right down the center. So we have BE. Then kind of diagonal, we have another diameter, goes right through the center. This is CF. And then exactly horizontal, we have a radius over here, D. And they give us that this is a right angle, and this angle in here is 51 degrees. And then we want to find the measure of arc DF and the measure of arc DEB. So the first thing that I like to do is I like to go through and find all of the angles that are missing. And so when I'm doing this, it's important to know that we're trying to find the arc measure. So like DF is the first one we're going to find, but those are the same as the central angle. So if I can find all of these angles on the inside, I can find any arc on the outside. So I already know that this one's 51. I know that a right angle is 90 degrees. So I'm off to a good start. And then I kind of get stuck. Like I'm not sure what to put here or here or here. And so this is where our full circles, semicircles, vertical angles all come in. So I always look for semicircles first. I think that's what you should do. So I see that I have one here. And that means that this right side adds up to 180 and this left side adds up to 180. Knowing the right side adds up to 180 is super helpful for me because I can find this missing piece by doing 180 minus 51 minus 90. So the whole thing adds up to 180. I can subtract these two off and I should get my missing part. So 180 minus 90 minus 51. And that gives me 39. Then I notice that I have vertical angles here, and not just because they're like on top of each other, because you could also say the same about this one and this one, but because they're created by two diameters. We have this diameter and we have this diameter. So those two diameters create vertical angles. So I know that this angle and this angle are the same. So that means this has to be 39 as well. You could also use this diameter, you know, this all adds up to 180, and you could do the same process we just did, but using it on this side instead of this. And our last chunk, you could do this two ways. You could use the fact that this is a diameter, so that this half adds up to 180, and so we could do 180 minus 39. You could also see that this and this entire angle are vertical. And so I could add up 90 plus 51 to get that side over there, which is what I'm going to do. And I get 141. So once you kind of like go through the process and you use your semicircles, use your vertical angles, you find all the pieces, then you can kind of go through and look at what arc it's asking for. So arc DF is from here to here. And that means I'm going to add up 90 plus 39. And 90 plus 39 gives me 129 degrees. So then DEB, I want to start at D again, go to E, all the way to B. Now there's a couple ways you could do this. You could add up 90 plus 39 plus 141, and that would give you all of your angles. You could also know that since the whole thing adds up to 360, you could subtract 51 and 39 from 360. I'm going to do the adding method. That's typically what I always do. So 90 plus 39 plus 141. Gives me 270. So this is kind of like the whole process, finding vertical angles, finding semicircles, full circles to be able to find all the pieces in between. I hope this helps.